Hello students, so we are learning about sets. In the last class, we learned about the different types of sets. So in today's class, we are going to learn few more topics under sets. To start with, we are going to learn what is meant by a subset. What is meant by a subset? So a set A is a subset of set B if every element of A is also an element of B, and it is denoted by this symbol. Understand the wording properly. A set A is a subset of set B if every element of A is also an element of B. Each and every element of a particular set should be available in the another set. Then only that particular set is called a subset of the other set. We will denote A is a subset of B. And this symbol stands for not a subset. If we want to say a particular set is not a subset of the another set, we will denote it by using this symbol, right? And very important properties under subsets are every set A is a subset of itself. Every set is a subset of itself because all the elements are available in that particular set. So we can say every set is a subset of itself. An empty set is also a subset of every set. These two properties you should remember when we are talking about a subset. So we will see now few examples for a subset. Now Q is a subset of R. What is Q? Q denotes the set of all rational numbers. And what is R? Set of all real numbers. And every rational number is available in a set of all real numbers. Yes or no? Yes. So Q is a subset of R. Then another example, say set A has the elements 1, 3 and 5. Set B is denoted in set builder form, which is equal to set of all x such that x is an odd natural number less than 6. X is an odd natural number less than 6. Then what are all the numbers it will consist of? Set of all x such that x is an odd natural number less than 6. So natural number starts from 1 and moreover it's an odd number. So 1, 3, 5. Right? So B will have 1, 3 and 5. Now see, A has an element 1, 3, 5 and B also has an element 1, 3, 5. So immediately what a type of set it will strike our mind? A and B are equal sets. Equal sets. Very good. Now we are going to check whether A is a subset of B or not. So for a particular set to be a subset of another set, what is the required criteria? Each and every element of this set should be available in this set, right? Now here 1 is available, 3 is available, 5 is available. So every element of A is an element of B. Therefore we can say A is a subset of B. On the other hand, we can even say B is a subset of A because every element of B is also available in A, and also B is a subset of A. So when we will call a set A is a subset of set B if every element of A is also an element of B. Hope you understood.
Let us see one problem. Given that n is equal to 2, 3, etc. up to 20. This is a set. Then write the subset of n whose elements are prime numbers. The subset of n whose elements are composite numbers. We can easily list out, right? Now what will be the solution for the first one? Let us denote the subset of n whose elements are prime numbers as x. So x will have, what are all the numbers? 2, 3, 5, 7, 11, 13, 17, 19. Isn't it? So this is a subset of n whose elements are prime numbers. And what will be the answer for the second one? Let us denote it by y. The subset of n whose elements are composite numbers. You know what are composite numbers, right? The numbers which are not prime numbers are called as composite numbers. So it will include the remaining numbers 4, 6, 8, 9, 10, 12, 14, 15, 16, 18 and 20. So we have written two subsets. which is asked in the question. Now clearly we can say x is a subset of n and y is a subset of n, because each and every element of these sets are available in the given set. Therefore x is a subset of n and y is a subset of n. Now let us see second example. Write down all the subsets of the set 1, 2, 3. They asked you to list out all the subsets of this set. What is meant by a subset? A set derived from the original set, right? Each and every element of the set will be available in the original set. So how can we find all the subsets of the original set? We can start with the subset having a single element. So we can frame like that. First, first we will start with the subset having a single element. So how we can write? Singleton 1, singleton set 2, singleton set 3. We have separated each and every element of the set. Obviously this is a subset of the original set, right? Because this element is available in the original set. Next we can derive the original set by having a sets with two elements. Then again these are also the subsets of this set. So this is the procedure to derive the subsets of a original set. What is the procedure? First write sets with single elements. Make it as a singleton sets. A set with one element you first list out, and then set with two elements, and then set with three elements, set with four elements. Likewise you can proceed till you obtain the original set itself. Right, this is the procedure to list out the subsets of the given original set. Now here we have only three elements. So first with one element we got three subsets. With two element again we will get three subsets in a combination 1, 2, 2, 3 and 3, 1. Then what will be with the three elements? Three elements will be the original set 1, 2, 3. So what are all the subsets? Therefore subsets of the set are, so while learning the definition of the subset itself, I told you null set is a subset of every set. So whenever when we are listing out the subsets of a set, first we should start with the null set and end with the original set, because we know null set is a subset of every set as well as every set is a subset of itself. I repeat, null set is a subset of every set and also every set is a subset of itself. Therefore, whenever you are listing out the subsets of any set, start with the null set and end with the original set. In between, you can list out the remaining subsets so that you won't miss out anything and you won't make any mistake, right? So first we are going to start with the null set, then sets having singleton sets having a single element, and then sets having two elements, and then the original set. Thus we listed out all the subsets of the given set. Let us see the next problem. Let A is equals to 1, 2, 3, 4, 5. On seeing this set, immediately what should strike your mind? This is set of sets, right? So one element of the set itself is a set. One element of a set itself is a set. This is set of sets. Which of the following statements are incorrect and why? Now look at the first question. 3, 4 is a subset of A. The set 3, 4 is a subset of A. Is this correct or wrong? The set 3, 4 is a subset of A. Is incorrect because this is incorrect because the set 3, 4 is an element of A. Is an element of A. The set 3, 4 itself is an element of A. When we are denoting a set, it should be denoted inside the flower braces, right? Here the set 3, 4 is an element of A and it is not a subset of A. Therefore, this statement is wrong. For a set to be a subset of another set, each and every element of it should be an element of the original set, right? Now look at the second question. The set 3, 4 is an element of A. Yes, this is true. This belongs to A. Yes, the set itself is an element. This is an element here. Therefore, this is true. Now look at the third question. The set 3 comma 4 is a subset of A. Now what they have expressed is correct, because here this set denotes the element of A. This set denotes the element of A. Now this element is written within a set braces. Therefore, this comprises of a set which is a subset of A is true. Now one element of A is written inside a set and hence it becomes a subset of A. Therefore it is true. Yes, this is correct. Now 1 belongs to A. The statement is correct because 1 belongs to the set A. Therefore it is correct. Now 1 is a subset of A. Is this correct? No. As I told you, whenever we come across the word set, it should be expressed within the flower braces only. Element only can be written simply without any braces. So if I say 1 is a subset of A is a wrong statement, because 1 is an element of A. This doesn't denote a set. Therefore, this is wrong. This is incorrect. Now 1 comma 2 comma 5, the set of 1 2 5 is a subset of A. This is correct because the element 1 belongs to the set A, 2 also belongs to the set A, and even 5 also belongs to the set A. Therefore, we can say the set 1 2 5 is a subset of A, which is correct.